I thank you very much and I say good morning. Dear student, dear learners, dear people who are following on this link, this is the lesson which is interesting and which is related to what we see in our daily life. Sometimes we are challenged by many things. But now I want to show the truth of things. Now the practical lesson is determination of the boiling point elevation. What do we call boiling point elevation? Is when you have, for example, water. You know that water boil when we are at the pressure of 1 atmosphere. The pressure of 1 atmosphere or 760 millimeter of mercury. The boiling point of water, is boiling point of water is equal to 100 degrees Celsius or centigrade. We can ask the question, if we put, for example, salt. We put salt. For example, we take 1 liter of water. 1 liter of water is equal to 1,000 gram. 1,000 gram or 1 kilogram. And here also we take other 1 kilogram of water, H2O. Here we put 58.5 grams of sodium chloride, or we call table salt, that salt we use. And here we put also 100 grams of glucose. And I can say that after heating, we can know that whether here temperature, after adding salt, for example, salt solution is greater than 100 degrees, or it is smaller than 100 Celsius degrees, or it is equal to 100 Celsius degrees. Here, what we have to know is to know what the effect of putting solutes in pure water or in pure solvent, to see how, if there is the effect on the boiling point. What we must know, every substance has what we call the constant of ebullition, or this constant of ebullition is called the ebullioscopic constant. This ebullioscopic constant, it is the change in temperature which is added to the normal boiling point of a pure solvent. It means that what we must know, that if we take pure water and the boiling point is 100 Celsius degrees, it means that anyhow the boiling point of the resulting solution will be greater than that of 100. But this delta T, change in temperature, correspond to delta T, ebullioscopic constant is delta T elevated, is elevation in temperature when you take 1 mole, and 1 mole of solute is in 1 kilogram of solvent. For this reason, you find that the volume which is at the elevated here it can be the volume, the temperature which is elevated here for table salt and for glucose. We can see whether are the same. 1 mole of sodium chloride is equal to 23 plus sodium mass, molar mass of sodium is 23 grams. Molar mass of chloride is 35.5 grams per mole. It means that per mole means that for the table salt, 1 mole is equal to 58.5 gram mole minus 1. And for glucose C6H12 or 6, it corresponds to 12 times 6 because carbon is 12, hydrogen is 1, oxygen is 16, plus 12 plus 6 times 16, and the molar mass in 1 mole, of course, the molar mass will be equal to 100 gram mole minus 1. It means that quantitatively, the temperature elevated, boiling point elevation caused by 58.5 grams of sodium chloride, which is the table salt, is the same as that used for 180 grams of glucose. You must know that in the solution, the table salt is powerful, is strong, it is dominant than the sugar, because the glucose is a sugar. Even for the top table sugar, to increase the same amount, the same level of temperature on the thermometer, it will require the same temperature. Means that delta TA here and here also on the thermometer there is delta TB. You must know that here delta TA exactly will be equal to delta TB because all are involving the same number of mole, whatever the case, whatever the nature of the substance used. If the amount of solvent is the same in kilogram, but the amount are different in mass but the same in number of mole, the boiling point elevation will be the same. It means that this delta T for table salt and delta T for glucose is what we call delta T elevation. Continue to enjoy my lessons. Don't forget to click notification icon, and also don't forget to click on subscribe. Don't forget to click like and comment in order to improve the future and the next lessons. Thank you very much indeed.